So in this video, we're going to talk about Multimedia Science's momentum and impulse demos. This is a set of 5 simulations that will help to illustrate both momentum transfer and the idea of impulse. Let's quickly go through the instructor's notes and talk about quickly each of the demonstrations. First demonstration asks the question, which would hurt more? An object that hits you and sticks, or an object that hits you and bounces off? So this simulation will help you show students which is which and why. The next simulation deals with the idea of follow-through, and by varying the time on the racket, you can increase the FT, the impulse, and therefore increase the change in momentum or the velocity of the ball. Then we have the Inelastic Collision simulation, where a hockey player hits a hockey puck at a goalie, and we see just what kind of velocity we can give the goalie. Thinking about movies where a hockey puck is hit and the goalie goes flying through the net and into the backboards. Is that realistic or not? So we can look at a number of different velocities of the puck, knowing what its actual mass is, and see exactly what kind of reaction can we expect to get out of the goalie, and how fast would the puck have to be going in order to get the goalie to go flying off in the other direction. The next 2 simulations talk about or are related to movies. I've probably seen plenty of movies where somebody is being approached and fires a shotgun or a high-powered rifle, and the person that's hit goes flying across the room or through the windows into the room of the house. And the question is, how realistic is this? What can we actually expect? I know when I first started teaching, my thoughts is that if people or a person was hit with a bullet, that they should go flying backwards. It turns out that that's not true, even if the collision is totally inelastic. So these simulations will help illustrate. There's a different guns, a long rifle, a magnum, a 50 caliber. Exactly what can we expect to happen if something, and we use a dummy in the examples, if a dummy or an object is hit with a bullet. So let's take a look at least a couple of these. Let's start with a follow-through. Here we can change the time by varying the spot at which the tennis racket will stop. So we start the motion with a close-in. You can see that the time on the racket, the ball spins on the racket, is very small. It turns out that the force that you can place on the racket, or at least most people, put the same amount of force no matter what the time on the racket is. And you can see that the final velocity is rather low. We'll reset this, and now we'll change. You probably want to do this a little bit at a time. We'll do the maximum. Start the motion. You can see now the time is like 3 times as much, and the velocity is 3 times as much. So if students want to increase the power on their tennis strokes, you want to definitely use follow-through. Let's take a look at the inelastic collision. Here we have the puck has a known mass, and we're going to change the, let's make this really pretty absurd, 500 miles per hour. And now we're going to measure what the velocity of the goalie can be, and you could have the students figure that out. If the goalie has a mass of 100 kilograms, and then you can see that pretty small, even with a probably unrealistic velocity for the puck. Let's reset that, and let's get this way up there. Let's do 1,500 miles per hour. Sure would want to be the goalie in this one. Let's start the motion, See, even there, the goalie is not exactly 6 miles per hour, is not flying back into the backboards. So interesting. I found it. I didn't really know exactly what these results would turn out to be before I did the calculations. All of these simulations have a discussion. So if you're having students run through these, they would have something to read that would explain exactly what's going on. Here's the equation for the inelastic collision between the puck and the goalie. So that's a quick peek at the momentum and impulse demos from Multimedia Science. I've used this with my classes and find that the students get a kick out of talking about the real life implications of impulse and momentum. It's great to talk about it theoretically, but this is a way of getting it into the real world. Also, it's a way of showing the students the results without having to shoot things around in the classroom, certainly not bouncing things off of students' heads. So if you're interested in finding out more about the momentum and impulse demos or any of the other many materials that have been created by Multimedia Science, physics, chemistry, games, experiments, simulations, challenges, teacher tools, game makers, please check out Teachers Pay Teachers at this URL. And as usual, thanks so much for watching.